All right, in this video, we're going to look at your review for lessons 4.6 to 4.9 to make sure that you're ready for the test. So in this first section, this is all about properties of the sine, cosine, and tangent functions, mostly with their graphs. But when the first one, it says which graphs are odd. Remember, to be an odd function, that's where if you rotate the graph 180 degrees. So if you're to take a graph and like on a piece of paper for the sine, cosine, and tangent function, and if you flipped it upside down, because it'd be the same as rotating 180 degrees, if the graph would look the same, then it's an odd function. If it wouldn't look the same, then it's not odd. But that happens with both the sine and the tangent functions. So both of those are odd functions. And an even function is where if you took the graph and reflected over the y-axis, it would be the same on both sides. And that happens with just the cosine function. And which graphs have zeros at multiples of pi? So that means that which graphs do they intersect at multiples of pi on the x-axis? And that would be both the sine and the tangent function. And which graphs have multiples at odd, or which graphs have zeros at odd multiples of pi over 2? Well, that one is, again, just the cosine function. And what are the asymptotes of the tangent function when x, so your values for x are between 0 and 2 pi? So remember, the asymptotes are where, remember, you can't divide by 0, so anytime the cosine is 0, because remember, the tangent is a sine divided by the cosine, so whenever the cosine is 0, then you're going to have an asymptote for the tangent function. And that happens at pi over 2 and 3 pi over 2. All right, so here it says, without using graphing or scientific calculator, find the exact values of the following. Now, on the test, I'm not going to be able to supervise you to make sure that you're not using a calculator. Remember, for moving forward, you do want to make sure you know the unit circle, so you know what these values would be. But for the time being, I cannot assess you on that since you are taking this online. So for this one, for these problems, the most important thing is just to know what the equivalent values would be for the sine, cosine, and the last one, the tangent function. So to figure that out, we're going to start with, so for the first one, so sine and cosine functions, remember, those repeat themselves every 360 degrees. So if I take 2,370 divided by 360, we get 6.583 repeating. Well, that means that it's 6 full rotations plus an additional 0.583. So we want to figure out, well, how many degrees would that be? So if I multiply that times 360, we get 210 degrees. So sine of 200, or let me write it like this: a sine of 2,370 degrees is the same as a sine of 210 degrees, and the sine of 210 degrees technically is negative 1/2. So technically negative 1/2 is the answer, but for the purpose of the test, you want to make sure that you know how to get the sine, that the sine of 2,370 degrees would be equivalent to the sine of 210 degrees. Let's take the next one. So the next one, we have the cosine of 3,210 degrees. So it's the same situation. The sine and cosine functions, again, repeat themselves every 360 degrees. So I'm going to take this 3,210 and divide it by 360. And when you do that, we get 8.916 repeating. Well, that means that it's 8 full rotations plus another 0.916 rotations. We want to figure out, well, how many degrees would that 0.916 repeating be? So if I multiply that times 360, we're going to get 330 degrees as your answer. So the cosine of 3,210 is equivalent to the cosine of 330 degrees. And technically, the cosine of 330 degrees is square root of 3 over 2. But again, I'm not going to be able to test you on that for the time being, maybe in the future, but at least for right now, the most important thing is just to know what this equivalent value would be, and that's a cosine of 330 degrees. All right, so for number 9, this time it asks us to find the tangent of 2,385 degrees. Now remember, for the tangent function, it repeats itself every 180 degrees. So for this one, we're going to take 2,385 divided by 180. And when you do that, we get 13.25. So that means that it's equivalent to 13 full rotations plus an additional 0.25 over. So if we just focus on that 0.25 and multiply that times 180 to figure out that quarter turn, how many degrees would that be? Well, 0.25 times 180 is 45. So tangent of 2,385 degrees is equivalent to the tangent of 45 degrees. And the tangent of 45 degrees would be the square root of 2 over 2 divided by the square root of 2 over 2. Because remember, tangent would be the sine over the cosine. So sine of 45 degrees would be square root of 2 over 2. Again, the cosine of 45 degrees would also be square root of 2 over 2. So when you divide those, we would get 1 as our answer. But remember, for the time being, since I can't monitor you and make sure that you're not using a calculator on these, the most important piece is to make sure that you know how to find the equivalent value using that periodicity theorem. All right, so for this one, we're going to match these equations with the graphs. And so let's make sure that you understand what's happening with each of these. So for the first one, it's dealing with the sine function. And it's going to go, or all these, I should say, are for the sine function. And for the first one, we're going to the left 3 pi over 4 radians and down 3. So since this is a matching one, personally, I think it's easiest to identify or narrow down the graphs that it can't be. So I understand that this has got to move down 3 units. So I'm going to look to see which one of these graphs move down 3 units. And I really have only 2 options. I have options C or F for this first one. So it's going to be one of those two. And now I'm going to look and understand, well, the plus 3 pi over 4 means it's moving to the left 3 pi over 4 units. So here on this graph, this would represent a fourth. So this would be 1/4, 2/4, 3/4. So I want to figure out which one would the starting position move from here to here. Because remember, the graph would look something like this and then come down. So that starting position is going to move right there, and that's going to be this graph. So this graph, we can see that that represents one period. So that's been moved to the left 3 pi over 4 radians, and it's been moved down 3 units. So that tells me that C is a correct answer for this first one. All right, let's look at number 11. So with number 11, this graph is moving up 2 units. So again, personally, I think it's easiest to identify which, or to narrow down which graphs we are going to be focusing on. So I want to look at which graphs move up 2 units. And it looks like my options would be A would move up 2 units, B moves up 2 units, and E moves up 2 units. So it's got to be one of those 3, either A, B, or E. So now let's look at what's happening with the rest of the graph. So we know that not only is it moving up 2 units, but it's going to move to the right pi over 2 units. So I want to figure out of these, which one moves to the right pi over 2 units. Remember, the starting position would have been here, would have gone up, and would look something like that. So I want to see, where is that starting position moved to the right pi over 2? Well, here it's moved to the right pi over 2 units, but notice it doesn't go up at the beginning, it goes down. So actually, that is not going to be the correct answer, so it's not going to be A. Looking at option B, did this one go to the right pi over 2 units and up 2 units? Yes, it does. Here it starts at that point, and then it repeats itself, so we could see that that one has gone to the right pi over 2 units. So my answer is going to be B. Let's just double check and see if there's anything I could have done wrong where E would be my answer. So if we go to the right pi over 2 units, nope, it's not going to be a starting point there. So that is not it either. Okay, so now I know that my correct answer has to be B. All right, let's look at number 12. So number 12, this one's looking at in terms of, instead of giving us an equation, they're giving us the translation. So this means that it's going to the right pi over 4 units and up 2 units. So just like the last one, it's got to, if it's moving up 2 units, it's got to be either A, B, or E. Well, right off the bat, it can eliminate B because we know for graph B, it moved to the right pi over 2 units. So it's not going to the right pi over 4, so it's got to be either 12 or 12's got to be either A or E. And so pi over 4 units, let's look at E, because I know with part A that it was pi over 2 is just to the left, actually, pi over 2 for this one. Okay, because technically that's where the full period would be. So it's not going to be A, but let's look at E. So E, remember, each one of these dash marks represents 1/4 of pi, or pi over 4. And so, yeah, we got to the right pi over 4 units, and then up 2 units. So your answer, your only possibility for that one would be E. All right, let's look at number 13 here. So for number 13, again, I'm going to start with this fact that it's going to go down 3 units. We want to figure out which one of these graphs moved down 3 units. Well, then our options are only C and F. So C and F go down 3 units. And then we want to figure out of those 3, which ones, oh, actually, you know what? D also goes down 3 units. I was kind of ignoring that one, but if you notice, that one goes down 3 units as well. So right now it could be either any of these 3, so I'm going to uncircle E here. It could be any of those 3, but remember that we did C already. C went with the first graph, number 10, and that's where it was going to the left, 3 pi over 4 units, where this graph is going to be going to the left 5 pi over 4 units. So I know it's not going to be C. So now I narrowed it down to D or F. And actually, both of these could be the correct answer, because if you look at this graph here, so 5 pi over 4, so again, moving it to the left, 5 pi over 4, so this would be 1 pi, 2 pi, 3 pi over 4, 4 pi over 4, 5 pi over 4 would be right here. So sure enough, it starts there, and that would be the shape of the sine function, because it moves to the left, 5 pi over 4, and down 3, so F would be correct. But if you said D, that one works too, because again, these each would be 1 pi over 4 units. So this would be 1 pi over 4, 2 pi over 4, 3 pi, 4 pi, 5 pi over 4 would be right here. And sure enough, that starts at 5 pi over 4 units, and it went down 3 units. So D or F. So this one, if you said D, if you said F, or even if you said both D and F would work. So that would be your answer for number 13. All right, let's look at another graph, another matching question. So this one, we're going to match these equations to these graphs. This time, though, we're dealing with, instead of translations, we're dealing with scale changes. So that means it's going to be stretched vertically or horizontally. Let's start with the first one here for number 14. So with the beginning there with 2 times, remember that means vertically it's going to be stretched to be 2 times the size. So that means instead of oscillating between -1 and 1, it's going to be stretched vertically, so to be twice the size. So now it's going to oscillate between -2 and 2. So let's see which graphs do that. So we would have A oscillates between -2 and 2, so does B. C goes between -4 and 4. D goes between -2 and 2. E goes between -2 and 2. And F goes between -4 and 4. Okay, so now I really haven't narrowed it down too much. I'm just narrowing it down to one of these 4. So let's see what's happening. Whoops. Let's see what's happening horizontally. So horizontally, we have this 2 times x. So remember, the way that I interpret that is that's going to be the reciprocal of 2 is 1/2. So it's going to be 1/2 the size. So let's figure out what the period would be. Remember, the period typically would be 2 pi. So if we take half of 2 pi, we get pi. So the period would be just pi radians. So out of these 4, I want to figure out, and by the way, too, we're dealing with the cosine function. So I want to figure out which one of these would oscillate between -2 over 2, but repeat itself every pi radians. So A repeats itself every 4 pi radians, so that's not it. B repeats itself every pi over 2 radians, so that's not it. Let's look at D. D repeats itself every 8 pi radians. E repeats itself every 2 pi radians. Okay, so you can see that that's one period, that's one cycle for the cosine function. And then it repeats itself again and again every pi radians. So our only correct answer would be letter E for the first one, or for number 14. All right, let's look at number 15. So number 15 is similar to number 14 in the fact that it's being stretched vertically to be twice the size. So that means it's got to be either A, B, D, or E. But since we just found E to be your answer for number 14, I'm assuming that that's not going to be the answer for this one too. Because this one is got our value there of 1/4. We're going to figure out how that's being affected horizontally. We take the reciprocal of that. The reciprocal of 1/4 would be 4. So that means it's going to be stretched horizontally to be 4 times the size. So that means one period is going to be 4 times 2 pi. So one period is going to be 8 pi radians. So I want to figure out which one of these is stretched so I'll have a period of 8 pi. And the only option for that is letter D, because you can see that in letter D, one cycle or one period is 8 pi radians. So answer for that one would be letter D. All right, let's look at number 16. So for number 16, this is telling us what's happening. So this says that So the 1/2 means horizontally it's being compressed to be half the size. Vertically, it's being stretched to be 4 times the size. So let's start with that, because that really narrows it down to be between C and F, because both of those oscillate between -4 and +4. So those are being stretched vertically to be 4 times the size. So now between those two, I want to figure out which one's being compressed half the size horizontally. So that means that 1 period is normally 2 pi, so half of that would just be pi. So I want to figure out which one of these repeats itself every pi radians. Well, that's going to be option C, because option C repeats itself every pi radians. All right, let's look at number 17. 17, this means that it's being stretched horizontally to be twice the size, and vertically it's being stretched to be 4 times the size. So that means my only options can be only C or F. So between those two, now we should be able to guess that chances are it's only going to be F, because we just did C as a previous answer, but let's just double check why that would be. So again, it's going to be stretched to be twice the size horizontally. Well, 2 times 2 pi is 4 pi. So that means 1 period or 1 cycle would be 4 pi radians, and that's what we have here. So our answer for that, number 17, would be F. All right, I'm getting sick of this color. Let's change colors here. I'll change this to green. All right, so for this one, it says write a rule for the scale change for the following equations. And so basically, a rule is just telling us exactly what's happening. So maybe on the test, I might ask you in words, what would this be? So let's start with what's happening vertically. It's going to be 1/8 the size vertically. So it's going to be compressed to be 1/8 the size. Horizontally, we see that we have 3 times x. So we would take the reciprocal of 3 would be 1/3. So this would be 1/3 the size horizontally. So if we were to do a scale change for this, we would say that, again, 1/3, it's going to be compressed to be 1/3 the size horizontally, and it's going to be 1/8 the size vertically. So that would be your rule for your scale change. For number 19, again, if we were to come up with a description for this one, the 4 would mean that it's being stretched vertically to be 4 times the size. And if I took the reciprocal of 1/5, I would get 5. So that means that horizontally it's going to be stretched to be 5 times the size. And so if we wanted to come up with a rule for the scale change, we would say, again, exactly what's happening is it's going to be 5 times the size horizontally and 4 times the size vertically. So that would be your rule for your scale change for number 19. For number 20, to find a rule for the translation, again on the test, I'll probably just have you describe in words what's happening. And so let's just go ahead and look at both with words and with our symbols with a rule for a scale change, or rule for a translation, what we would get for this one. So the fact that we have x plus 75, remember we have to do the opposite. So instead of going to the right 75 degrees, we would describe this as saying that we're going to go to the left 75 degrees. So for a rule for a scale change, we would say it'd be x minus 75 degrees. In that minus 2, we treat that exactly how it looks. In words, we would say it's going down 2 units. As a rule for a translation, then we would just write down y minus 2. So that would be your rule for your translation for number 20. For number 21, again, for our rule for a translation, if we're to describe this, exactly what's happening, this x minus 45 means it's moving to the right 45 degrees. So as far as coming up with a rule for that translation, I would say x plus 45 degrees. This plus 1 tells you, again, exactly what's happening vertically. So this would be, it's going up 1 unit. So we would just write that as y plus 1. So that'd be a rule for your scale change. But again, on the test, I'll probably have you just describe it in words, saying that it's going to move to the right 45 degrees and up 1 unit. All right, for number 22, it says write an equation for the sine function given the rule for translation or a scale change. All right, so this means for number 22, the x plus 5 pi over 2 means it's moving to the right 5 pi over 2 radians. The y minus 4 means it's moving down 4 units. So to come up with my equation for this one, again, using for a sine function here, I'm going to say it's going to be y equals a sine. That x, so again, it's moving to the right 5 pi over 2 radians, which means as the equation we would do the opposite, so it would be minus 5 pi over 2. And that minus 4, that's exactly what's happening, so it's moving down 4 units, so we just have minus 4 at the end. For number 23, Again, we do the opposite of what's happening. If I was to describe this in words, we would say, well, for the rule, it goes exactly as we say. Remember, a rule for translation, anytime we're dealing with a rule, that tells you exactly what's happening, just like if you were reading a rule for a rule book. So this means it's moving to the left 7 pi over 6 radians, and it's moving for the y's, it's exactly as we'd expect it, again. So it's moving up 9 units. So it's going to move to the left 7 pi over 6 radians, and it's going to move up 9 units. But when we go to an equation, we do the opposite for the x. And so, again, we're dealing with the sine here. So this would be y equals the sine of x plus 7 pi over 6 radians. And that plus 9, we leave that exactly as it's happening for the y value, but for the x, we do the opposite. And so it would be x plus 7 pi over 6, but then we'd have plus 9 after we take the sine. All right. For 24 and 25, these got shifted down to this page for some reason, but this is still in the same section. Again, we're dealing with a rule for a scale change here. And we want to come up with an equation for the sine function. So vertically, that happens exactly as we'd expect it. So we would have y equals 4 times the sine, and then we'd take the reciprocal for the x. Reciprocal of 1/5 would be 5, so we would say 5x. Again, for this one, vertically, this is going to stay the same, so I'm going to say y equals 1/8, 1/8, the sine of, we take the reciprocal of the 3, which is 1/3, or so if you say 1/3 x, or if you said x divided by 3, it's the same thing. So you could say y equals 1/8 the sine of x divided by 3, or if you said y equals 1/8 sine of 1/3 x, both of those mean the same thing. All right, so for number 26, we're trying to find what the phase shift and vertical shift would be for these two problems. So the phase shift, remember, that's referring to just what's happening horizontally. So what's the horizontal shift for that graph? And so I'm just going to abbreviate that as PS for the phase shift. So for the phase shift, we're going to go, so the opposite of x minus 5 pi over 2. That means, so when we see minus 5 pi over 2, remember, we're going to do the opposite. So it's going to go to the right 5 pi over 2 radians. So we can just say 5 pi over 2, or if you said it in words, we just say right 5 pi over 2. The vertical shift, remember, that's dealing with exactly what's happening here. So that would just be up 4. If you just said positive 4, just 4, that's describing your vertical shift. All right, let's look at the next one. So again, for the phase shift, we do the opposite of what's happening here. So the opposite of 7 pi over 4 would be negative 7 pi over 4, or you could describe it in words saying it's going to the left 7 pi over 4 radians. And the minus 8 for the vertical shift just means that it's going down 8 units, or you could just say negative 8. All right, let's look at number 28. So here we're describing the amplitude and the period. So the amplitude, remember, is the absolute value of whatever we have here. The absolute value of 1/4 is just 1/4. So that means it's going to be 1/4 the size vertically. So it means instead of oscillating between 1 and negative 1, it's going to be going back and forth between 1/4 and negative 1/4, basically. Because it's going to be compressed to be 1/4 the size vertically. Okay, so the period, we get that from this. Now remember, we don't just take and use that 2, or take the reciprocal of it as 1/2. So that means it's being compressed to be 1/2 the size horizontally. Well, remember, typically the period is going to be 2 pi. So if I take 1/2 of 2 pi, I just get pi. So the period here would just be pi. Do the same thing for the next one. So for the next one, again, to find the amplitude, it's the absolute value of that value there, which is 3. So the amplitude is 3, meaning that the graph is going to be stretched vertically to be 3 times the size. So instead of going between negative 1 and 1, it's going to go between negative 3 and 3. Okay, so to find the period, remember, we take the reciprocal of that. So that's 5 over 2. So we always do the opposite of the reciprocal. What happens with the x? So reciprocal of 2/5 would be 5/2. So that means it's going to be stretched to be 5 over 2, or which would be 2.5. So it's going to be 2.5 times the size horizontally. Which, if we wanted to figure out what that would mean as far in regards to the period, remember the period typically would be 2 pi radians. if we multiply those together, we would get 5 pi. So the period would be 5 pi radians. All right. For number 30, this summarizes these last couple of problems. This puts all of it together between our translations and our scale change, so we can figure out what our phase shifts, our vertical shifts, our amplitude, and our period are going to be. So let's start with the amplitude. That's easiest to find. That's just the absolute value of 4, which is just 4. And the period, use a different color here. So the period, remember that's the one that we got to do the most work for. So the period, we see that we have, this is all being divided by 3. So that tells me that this is the same as, inside of parentheses there, we could think that is the same as 1/3 times x plus 5 pi, if that helps. So we're going to take the reciprocal, either way, we're going to take the reciprocal of that 1/3, which is 3. So that means horizontally it's being stretched to be 3 times the size. Well, 3 times 2 pi would be 6 pi. So we get the period from taking the reciprocal, or the opposite of what happens with the x. All right, let's look at the translations here. So the phase shift is going to be looking at the fact that we have x plus 5 pi. So do the opposite. So it'd be negative 5 pi, meaning it's moving to the left 5 pi units. And then the vertical shift, what color haven't I used here? Let's use purple. So the phase shift is a the vertical shift is the +2, meaning it's moved up 2 units, or we could just say it's a +2 there. So that's how you could find the amplitude, the period, the phase shift, and the vertical shift for that function. Again, I think the trickiest one to find is the period. That's when we have to do the most work. All right, let's look at number 31. So for number 31, let's start with the amplitude again. So the amplitude is going to be whatever happens there. So that's just 1/5. The absolute value of 1/5 is just 1/5. The period, use red again. The period is where we're going to have to do the most work. And so I see that this 8 is written outside of there. That means we're taking 8 times those values. So 8 times, we're going to take 8 times x. We're going to take the reciprocal of 8, which would be 1/8. So that means that it's actually going to be 1/8 the size horizontally. Well, if I multiply that times 2 pi, I would get 2 pi over 8. And we want to reduce that. That reduces to 1/4. So it's going to be 1/4 the size, or it's going to repeat itself every pi over 4 radians. I think I said 1/4 the size. It's going to be 1/8 the size, which means that it's going to repeat itself every pi over 4 radians. Okay, let's find the phase shift. So the phase shift, remember, is referring to the horizontal shift, or what's happening horizontally. So we get that from this value. Now remember, anything that happens with the x, we do the opposite. So the opposite would be to the right 3 pi over 2 radians. We can just say positive 3 pi over 2. And the vertical shift is that -4, meaning it's going to go down 4 units. So that's how you'd find the amplitude, the period, the phase shift, and the vertical shift. So that's the end of your review. So hopefully that answers all the questions you may have had. If not, please make sure that you meet with me and go over any of these problems so I can make sure it's a little bit clearer so you can do better on the test.